Here we're looking at example 1 from our 3.1, 3.2 set of notes. We're asked how many solutions do the following systems have? Now, just in looking at this first one, we notice that it's in standard form. And one thing that really helps us out, because unfortunately we don't have a graph, is we have to go ahead and throw things into y equals mx plus b, if we want to determine again how many solutions there are. So for our first one, we have 3x minus 5y is equal to 7. Solving for y, we would subtract 3x from both sides. End up with negative 5y is equal to negative 3x plus 7. Dividing both sides by this negative 5. Here they cancel out. So then we have y is equal to 3/5 x minus 7/5. Because again, positive divided by negative, we get that negative. So there is, again, our red top equation in terms of y equals mx plus b. Now looking at our green one, we have to do pretty much the same thing. Make this into y equals mx plus b. So we have 4x minus 6y is equal to 9. We're first going to subtract this 4x from both sides. We end up then with negative 6y is equal to negative 4x plus 9. Dividing both sides by negative 6 to get y by himself. We end up then with y is equal to negative 4 divided by negative 6 will simplify down to be positive 2/3 x. 9 divided by negative 6 comes out to be negative 3/2. So here is, again, our green equation in terms of y equals mx plus b. Now, when we notice that we have different slopes, that means that these will not be parallel with one another. So they have different slopes. That immediately rules out parallel and, in fact, that they are the same line. Because graphically, just a quick sketch, here's our red one. Let's say this is what he was. Here is our green one. Not the exact same slope. Somewhere they will cross at some point. As long as they just have different slopes, they'll cross somewhere. And as a result, this would yield then one solution. Looking at our second one, we're going to do pretty much just the same exact thing. Get things in terms of y equals mx plus b. So if we subtract 4x from both sides, we would end up then with negative 2y is equal to negative 4x plus 3. Divide both sides by negative 2. Here we end up then with y is equal to negative 4 divided by negative 2 gives us positive 2x. Positive 3 divided by negative 2 gives us negative 3/2. So here is our equation in terms of y equals mx plus b for our blue line. For our purple one, we have, if we were to add 8x to both sides, we'd have 4y is equal to 8x minus 6. Divide both sides by this 4. On the left they cancel out, leaving us then with just y is equal to, looks like 2x. Negative divided by a positive gives us a negative. And then 6 divided by 4 can be simplified down to be 3/2. So here's our equation for our purple one in terms of y equals mx plus b. We notice that they have the exact same slope and they have the exact same y-intercept. So believe it or not, these are in fact the same exact line. And because of that, we would have infinitely many solutions. Now looking at our last one, this one's already in terms of y equals mx plus b, so we're good there. We just have to solve for this bottom one. adding 4x to both sides, we would end up then with 2y is equal to 4x plus 12. Dividing both sides by 2, we end up then with y is equal to 2x, because 4 divided by 2 gives us 2x. And then 12 divided by 2 would give us our plus 6. Now when we compare that with our original other line, originally the black one was 2x minus 6. Notice that they have literally the exact same slope, different y-intercept. Well, then those are going to give us two parallel lines. So graphically, just again a quick sketch, you would see for the red one, or I'm sorry, for the black one, you would see something like this. And for our red one, you would see something like this. But again, they're parallel with one another because they have the exact same slope, different y-intercept. So then this one would be no solution. All right. So again, that's really how we identify how many solutions there will be. You're looking at things in terms of y equals mx plus b, and then looking at the slopes and y-intercepts to see which scenario you're in. If it's one solution, all they need to do is have different slopes. If you're in infinitely many solutions, they literally have to be exactly the same line in terms of y equals mx plus b. If you're looking at no solution, they have the same slope, different y-intercept. So kind of going back to the definition, I think we should throw that in there. For one solution, we would have different slopes. That's the criteria. For no solution, they have the same slope, different y-intercept. We could even see that from the graph. Different y-intercepts, but same slopes. And for infinitely many solutions, they are literally the same line, so then they have the same slope, same y-intercept. But again, that is example 1 from our 3.1, 3.2 set of notes.